my name is Megumi, and I'm going to talk to you about correlation and cause and effect and how the distinction is important in science. Scientists investigate the world to understand how it works and to use that knowledge to better people's lives. Most often, we try to understand what makes the world function the way it does. We call this a mechanism, an explanation of how or why something in the world works the way it does. The first step in any science project, it starts with an observation of a trend or a pattern. A pattern can be thought of as a relationship between two things that happens over and over again, and we can call this a correlation. For example, if you have a spring, you notice that anytime you apply a weight on the spring stretches. We can plot a graph of this relationship looking at the length of the spring and the weights applied to it, and we notice that there is a pattern. The more weights that you apply to the spring, the longer it stretches. Causality is a relationship where one thing causes another, so we can call this cause and effect. Once we find that there's a correlation between two things, we might want to find out if the one thing is causing the other. And it's really important to distinguish between correlation and causation, because sometimes two things can happen together by coincidence or be related by another third factor. With the spring and the weights, it's really easy to find which one is causing the other. When we put the weights on the spring stretches. But stretching the spring doesn't magically cause the weight to appear. So we can say that the weights are causing the spring to stretch. And this mechanism can be explained by mass and gravity. The mass of the weights are being pulled towards the earth by gravity, and this force is making the spring stretch. This is an example of a pattern where we can clearly identify the cause and effect. So the distinction between correlation and cause and effect is especially important when we think about medicine and how our DNA affects our health. For example, there is a disease called Huntington disease that causes people to have uncontrollable twitches and brain problems. When scientists looked at the DNA of the people who have Huntington disease versus the people who don't, they made a big discovery that there's a change in the DNA among the patients that is not present in the people who don't have the disease. And we can say that this change in the DNA causes people to have Huntington's disease. On the other hand, there's another brain disease called Alzheimer's disease. When scientists look at the DNA of the patients and the people who don't have the disease, they notice that there's a pattern. There's a change in the DNA that is more common among the people who have Alzheimer's disease. But having this specific DNA sequence didn't guarantee that a person would get Alzheimer's disease, and people who didn't have that DNA sequence also could develop Alzheimer's disease. In this case, we can say that there's a correlation between the DNA and Alzheimer's disease, but not a causation. When we look at patterns, some of them can be very easy to identify what is the cause and what is the effect. In other cases, correlations and cause and effect can be very difficult to distinguish. In many cases, two factors can influence each other in what we can call a feedback loop, or we can have a chicken and egg problem where we don't know which causes the other. Aging is a very complex biological process, and it has many factors that contribute to it. What I'm interested in is to look at how the nervous system affects the aging process of our bodies. The nervous system is composed of our brain, the spinal cord, and all the nerves that innervate the tissues throughout our bodies. When we normally think about aging and the nervous system, we think about diseases of the brain that tends to happen when we age. So for example, like Alzheimer's disease. And in these cases, we're looking at how aging accelerates the processes that contribute to these diseases. However, we can also look at this problem in the other direction by looking at how the nervous system function affects aging. Scientists have observed a pattern or correlation that these diseases can show alterations or changes in how the nervous system functions. Many people think that these changes in the nervous system functions are caused by the disease itself. But what if the changes in the nervous system are also contributing to the progress of the disease and also contributing to the progress of the aging process in our bodies? Instead of looking at how aging causes changes in our nervous system, we're investigating how the nervous system function causes changes in the aging process.